It is Monday, May 11th, 2020, and I have an opportunity to talk to someone I've been wanting to talk to for a long time. He is a renowned uh, doctor. He is a renowned thought leader. He's a renowned, just interesting person to talk to about a whole bunch of stuff, especially related to weather, climate, Atlanta. And so I actually saw him maybe a year or two ago at Atlanta Studies, and his conversation on climate change and heat island effects in Atlanta blew my mind. And so I've been following him ever since, and I finally have a chance to talk to him. And his name is Dr. Marshall Shehperd, and he's going to explain to you all the things that, well, not everything that he knows, but he's going to explain a lot of things that he knows. So with no further ado, Dr. Marshall Shehperd.
Hey, thank you for having me on the podcast. I mean, it's an honor to kind of talk to very broad and different types of audiences than perhaps I often talk to. So just as a brief introduction, I'm Dr. Marshall Shehperd, but feel free to just call me Marshall.
Okay.
I'm an academic, but I don't get hung up in a lot of those academic ivory tower things. I like to kind of be relatable and real with people. But I am the director of the Atmospheric Sciences program at the University of Georgia, and I'm a full professor there, the Georgia Athletic Association Distinguished Professor. I guess it's some fancy academic title that they gave me. But I before I came to the University of Georgia, I spent 12 years of my career at NASA, which you have on your shirt.
I represent.
Yeah, I represent for NASA. I was at NASA Goddard Space Flight Center, which is in the DC area, one of NASA's largest centers, which, by the way, people used to always say, oh, do you work for the Kennedy Space Center, or do you forecast for the space shuttle launches? Because that's kind of the narrow view that people have of what NASA is. I was a part of the larger Earth Sciences program. So I was there 12 years, deputy project scientist for a mission called the Global Precipitation Measurement Mission, which is in orbit right now. But then left there in 2005 and joined the faculty at UGA. I grew up in the Atlanta area. My wife grew up in the Atlanta area. Now, I'm a suburban kid. I grew up in Canton.
Okay.
But wife actually grew up in Atlanta with the Brown High when it existed down off of Canton, it lived in the Cascade Road area. So we are native Georgians.
Nice. And so I love that. Makes it even more special because when I saw your presentation at Atlanta Studies a few years ago, the first thing that really struck to me was like you had a very concrete specificity to like what Atlanta's weather was looking like. And can you explain to people the thing that kind of what Atlanta's weather patterns kind of look like in terms of like a heat island effect?
Well, I got to kind of do a little context here. So there's something called the urban heat island. Mm-hmm. Most cities have them, where the cities are warmer than the surrounding suburban and rural areas because of all the asphalt and lack of trees in the city, and the fact that pavement and concrete retains heat and then gives it back up at night. And trees, when you have trees, that actually does something called evapotranspiration, which cools the air. So when you have less trees, which most cities do, these things conspire to give you an urban heat island. On top of that, you've got large buildings and skyscrapers, which change the way the wind flows in and around cities too. And so what I was talking about in that particular talk that you heard is that this urban environment, the heat island, the buildings, maybe even the pollution, can change the way it rains around Atlanta sometimes. Not all of the time, primarily during the warm summer season and whatnot. But we have found in some of our research at the University of Georgia that Atlanta can sometimes create its own thunderstorms, for example, because of all of that heat and all that lift from the city, or it can modify existing storms. We've published many papers in the peer-reviewed literature on that. And so that's something that we've studied around the world. It's not just something unique to Atlanta, but Atlanta is just one of the places we've looked at. But the urban heat island is always there. It creates its own issues because it's warmer in cities. So at night, it doesn't cool off as much. And so people in vulnerable communities and whatnot may have additional challenges in terms of heat stress and heat mortality related issues. So there are all kinds of interesting weather related issues, urban planning related issues, even environmental justice related issues around that particular work. But overall, our weather is governed by large weather patterns here. But there are certain situations where that urban environment can certainly make its presence felt.
And I want to just bring up two things. I still remember this from your presentation I thought was fascinating. One of which was you talked about how it rains in specifically different parts of Metro Atlanta more than the other. Can you explain what that was actually about?
Yeah, so we found in some of our work that on average, during the summertime, when you don't have large fronts coming through or large major weather systems, we found that there's a preferred downwind down in the sort of downwind part of the city for Atlanta on average. That's the eastern and northern and northeastern suburbs. So from around, say, just from around up around the northern loop of I-285 all the way around Gwinnett and DeKalb County and eastward in the suburbs, they tend to get a little bit more rainfall and a little heavier rainfall on average in the summertime. And that's because as the city sort of stimulates these storms through the lift and the heat island, and then they translate downwind, you can see a bit more rainfall. Our studies have shown that. There's a recent paper that we published, Jordan McLeod, myself, and a colleague named Chip Conrad at University of North Carolina, that you can find in a journal called Urban Climate, which is a peer-reviewed journal where we talk all about it. So if you live on the western side of Atlanta, perhaps in the summertime, you may not get as much rain or lightning, by the way. There's studies by colleagues up at the University of Kentucky that have shown that there's actually more lightning strikes, flashes downwind of Atlanta too. And it's just sort of related to the same things that I've been talking about. So a natural question may be, well, how the heck does a city create or modify rainfall? Well, there are four sort of hypotheses in the scientific literature. One is the urban heat island, because we know that heat tends to be destabilized and want to rise. Two, the buildings. When wind blows through buildings or a stand of trees, it converges and lifts. Three, cities can actually force storms to go around them. There was something called bifurcation. We see that often. And then fourthly, all clouds on this planet, no matter where we are, have to form from some type of nucleus or seed. We call them condensation nuclei. And so cities are rich in those pollution particles and so forth. So those four things together somehow can help modify rainfall on those warm summer days sometimes. So that's the kind of research that I've spent a good portion. It's not the only type of research I do, but one of the things I'm fairly well known for is my work on how urban environments affect rainfall, storms, and flooding.
Right. And speaking of that, I want to actually go to the west side of town. There was something you mentioned about Six Flags, which I thought was interesting, and why that particular place flooded.
Well, that was kind of going back to those of us that have been in Atlanta, were in Atlanta in 2009, might remember that 500-year flood. We had a really bad flood in 2009. By the way, a 500-year flood, let's do a little education here, doesn't mean it floods every 500 years.
Okay, a lot of people are going to think that.
Yeah, a lot of people definitely think that. A 100-year flood means it happens every 100 years. What a 100-year flood, or what a 500-year flood, I'll use that as an example, means is that there's a 1 in 500 chance that it can happen in any given year. So what we're seeing was, as climate is shifting and warming, and where atmosphere has more water vapor available to it, we're seeing these extreme flood events happening more frequently. So you might get 4 100-year flood events in Atlanta in a given year. You might have 2 500-year flood events. So one of the things about cities, because of the impervious surfaces, the pavement and the roadways, when we put those things in cities, they change the natural water cycle. Now, those of you listening to this podcast learned about water cycle in 4th grade, condensation, evaporation, precipitation. And one of the terms is called infiltration, which means as it rains, the water seeps into the soil. Well, when you've got a parking lot at a Best Buy or at a mall, it doesn't seep into the soil, it runs off. So the urban water cycle is very different than the natural water cycle. And so you get a lot of runoff into the streams and lakes. You don't get water infiltrating into the soil. And so that can lead to flooding. And so we saw in Six Flags, for example, and many places around Atlanta for that matter, rapid flooding. Urban flooding is not just a function of the rain that falls from the sky. It's also a function of the impervious surfaces, how water is being managed in dams, and something you might not think about. When planners and engineers were designing Atlanta or any other city back in 1960, 1970, the stormwater management and runoff engineering assumed that it was going to rain the same way in 1970 as it does in 2020, and it doesn't, because of climate change. It's raining much harder now. So all of those things that I just mentioned are conspiring to lead to worse urban flooding for us.
Okay, now I want to jump into the conversation of climate change, because you've done now at least, I don't know how many videos of you are on YouTube now talking to people about climate change from every perspective possible. Sure. And you have 3 TED Talks about climate change. What do you say to people who think that climate change isn't real, or that it's made up, or something like that?
Yeah, I get all of that. I talk to people at the White House or the Waffle House about climate change. I don't care. But I do get invited up to those large policy briefings. Now, the good news is I think most people here oddly, in the United States is one of the few places around the world where there's still a debate about this in some people's minds. Most countries actually get it. But you have to understand that much of that denialism about climate change comes from something that the author of The Jungle wrote, Upton Sinclair, when he said that it's difficult to get a man to understand something when his salary depends on him not understanding it.
I
If you
like that.
think about that quote that up and you're seeing that, by the way, with COVID-19 and some of the denialism with that too. But so a lot of people's jobs and their industries depend on denying climate change, and so that's a lot of what's going on there. But we've kind of gotten past that. There's some lapses in climate literacy. If you go and look at sort of math and science literacy in this country in general, we lag other countries significantly. And so when you talk about, it's very counterintuitive to someone that we can have climate change or global warming, yet have a cold day or a snowy day. So I get people tweeting me when it snows, like, "Hey, what happened to global warming? It's snowing." I was like, "No, that's weather. I mean, weather is your mood, climate is your personality. They're different. Today's weather doesn't tell me anything about climate change." So we got the sort of economic interest. We've got the lack of science literacy, and then some people just aren't certain. Some people will say, "Well, Dr. Shehperd, the climate changes naturally." I'm saying, yeah, of course it does, but that doesn't still mean we can't change it too. I mean, look, grass grows naturally, but when you put fertilizer on your lawn, it grows more rapidly. So you have intervened in that natural process. Well, that's what we're doing to the climate system. And so, we just kind of keep at it with the messaging. And I think people for themselves are seeing the Hurricane Marias and Harveys, the wildfires in Australia. So I think a lot of people are just sort of seeing things happening for themselves and realizing, oh, this isn't about a polar bear, or it's not about the year 2080. This is happening now.
One of your TED Talks, I believe it's one of your 2012 or 2011 TED Talks, you mentioned this thing that the linkage between climate change and like consumer prices.
Yeah, well, that's the way we have to talk about climate change to the average citizen. You can't talk about polar bears or sea level rise in Borneo or something like that. You got to bring it down to these kitchen table issues. So climate change is affecting the price when we see reductions when we see a lot of drought, for example. We had a big drought in the Midwest a few years back, and things like cereal prices, corn, wheat, bread, all were impacted. Whenever we have a major hurricane barreling through the Gulf of Mexico, watch the price of gas for our cars, because a lot of those oil rigs get shut down. So there's economic impacts of climate change. Now, when we have climate change, there are mosquitoes that carry dengue fever and other tropical diseases that don't have to live in Costa Rica anymore. They can maybe survive in southern Georgia or maybe eventually in Atlanta. I was at a conference one time, and there were all these Canadian doctors at the hotel, and they were there learning how to treat Lyme disease. They didn't have Lyme disease in Canada several decades ago. Now they do, because that tick that carries it can live. It's warm enough. So you got health implications. You have economic implications, infrastructure implications. We have hurricanes destroying bridges and roadways and over flooded dams from all the intense rainfall. These are infrastructure issues. So my point is, people's kitchen table issues are impacted by climate change. People get COVID-19 because they see people getting sick and perhaps unfortunately even dying. It's not as obvious to people how sea level rise or hurricanes and these types of things are linked to climate change and are also causing deaths and economic despair.
Right. And one of the things I liked about a lot of your speeches that you talk about, you bring those connections to people. The other thing you bring up is this issue of, for example, you mentioned Hurricane Harvey, which was a lot of people were saying, well, we didn't know that this hurricane was going to happen. And you have the data, you write for Forbes, you even have a Forbes article that predates Hurricane Harvey and this intensity. Why do you think people don't seem to want to believe the science and believe the warnings when it happens?
Well, it's the same. Well, we see it all the time in those examples you gave. We see it when people will drive across a flooded roadway, when we tell people to turn around, don't drown. We see it when a Category 5 hurricane like Michael is headed towards the Florida coast, and you got someone saying, I'm not leaving my home. There's a couple of things that I've talked about. One, I think, is something called optimism bias, and that is that people just have this perspective that the worst thing won't happen to them, but yet they have this sort of imbalanced perspective that they'll win the lottery, for example.
Yeah.
They'll go buy a Powerball ticket with very little chance of winning that, but they think their chances of winning that are higher than getting hit by a hurricane. The hurricane has a much greater chance. So there's optimism bias. There's also something called normalcy bias. These are psychology terms, but they're relevant. People think that just because they've lived through one hurricane, they'll live through them all. Because I've driven through one flooded road, I'll make it to the next one. But by their very nature, Harvey or the wildfires in Australia or Hurricane Maria are anomaly events. They're not the normal. So just because you've lived through a garden variety flood or hurricane or maybe a Cat 1, you haven't experienced a Harvey or you haven't experienced an anomaly event. And so the outcomes are going to be different than normal. So those are challenges that we often see. And then there's actually Dunning-Kruger effect. You've
Yeah, I was
heard
going to ask you about that. Yeah.
me talk about it. People just think they know more than the experts. Oh yeah, the Farmer's Almanac tells me this, or the groundhog. When actually we're using very sophisticated computer models, and so people think they know more. They think their anecdotal experiences carry more weight, and frankly, sometimes people just what I call wish cast. They wish cast that the hurricane isn't going to hit their house. They wish cast here in the South that we're going to get a snowstorm so that we can have a snow day. And so these are all sort of, that's why you're seeing more in meteorology and climate these days. There's a move towards more people being involved in what's called the social sciences aspect. So how do people consume information, the psychology of it, how to best communicate.
Right. And one thing I wanted to ask you about, which was you've done, like, the thing is, you've done so much work on it. It's almost kind of undeniable. Like, you and a lot of people you work with in different organizations, it still seems that there's like this cognitive bias that people have against not even you personally as a person, but just like this idea that weather is changing and that maybe we're having something to do with it. Can you kind of explain what that was?
Yeah, I think that's not as, it's out there. I don't think it's as prevalent as we think it is. I think the people that say it are just very loud. So if you look at the Six Americas study from Yale Climate Communication, they survey America every year, and it breaks out into Six Americas. Now the dismissive is one of the six groups. They're like 9%. But they're really loud on social media and in various places. So you think there's more of that out there than there is. But yeah, there are certainly people that say, I'm a scientist of faith, for example. There are people that come up to me and say, well, I don't believe humans can change God's creation. Well, I was like, have you seen the ozone hole or pollution? Or look at how clean the air is now that most people aren't driving because of the social distancing. So that's one of the things that I hear. Some people just believe that there's this natural system, varying system, and Earth will fix itself, so to speak. But what you miss in that is that, yes, the natural system of Earth is definitely there in ecology, environment, and climate. But for the first time in history since 1850, you've got this foreign forcing function on the system called us and the things that we do. And so we haven't seen that there's no precedent for our impact. So we don't know how our impacts going forward are going to muck up the system, if you will. And I said, M.
Oh, it's all good. I cuss on here sometimes.
Yeah. Okay.
One thing I wanted to ask was that there was, in one of your other TED Talks, you talked about specifically, you said, I'm going to stick on 1850 for a second. You said that maybe like in the 4,000 years or so preceding, it seemed like the planet was cooling. And then since 1850 or so, it seems like it's just rapidly increased. Can you explain what that was?
Yeah, no, what I was showing there, no, actually, it's not cooling. I was showing in the press 400,000 years.
Yeah.
And what I was showing is that there's this natural cycle of warming and cooling. And in those cooling periods, those are the ice ages. Those are called the Milankovitch cycle. They happen naturally. They happen, you have this natural peak. But what you see when you get to 1850 and beyond is it goes way up here. So it gets beyond that natural bound and goes way up here. So that's that human forcing that I'm talking about. So we've gotten outside of that natural cap or limit on the variability. But yes, we have ice ages. We'll have ice ages. That's a part of the natural cycle. But on top of that natural cycle, just like on top of a Major League Baseball player's home runs, they use steroids, they hit longer and more of them. We have a human steroid on top of the climate system that's changing that naturally varying system.
Okay, and what in particular made 1850 so significant?
Well, that's when the start of the Industrial Revolution, when we started learning how to burn fossil fuels and things like that. We started realizing, oh, we can dig stuff up out of the ground from dead plants and dinosaurs and things that have been compressed into oil and coal and gas, and we can burn it. But when we do that in our cars or in the power plant, all of that energy and carbon that has been stored for millions of years is rapidly released into the atmosphere, so we get out of balance. We have a greenhouse effect. The greenhouse gases are important for us to live on planet Earth. If we didn't have a greenhouse effect, we wouldn't survive. So there's evidence of a greenhouse effect because we survive every night. If otherwise, we'd be too cold. But the problem is when we have too much entering the system too fast and also entering into our oceans, we're out of balance, and so we start warming.
Right. One of the things I wanted to ask you in particular is like this idea of the warming oceans and how that affects climate change, because a lot of people are trying to, like, I'm starting to see more people talk about this connection of climate refugees and like migration in America. And I know that's a big, broad topic, but Could you maybe break down parts of
Well,
that?
I mean, I don't, that's a different topic from
Yeah.
well, I'll start with the first topic first. Oceans are part of the climate system. So as they're warming, they also modify our weather patterns. They strengthen hurricanes. They change the ocean current circulations, and all of those things regulate weather. We also see, because of the expansion of water as it heats up, and also melting of some of the sort of the West Antarctic ice sheet, Greenland, et cetera, we see sea level rise as well. So those are the physical impacts on the ocean. But of course, then as you get sea level rise, you start flooding out certain island nations, or you get weather pattern changes. Certain countries in the Sahel, Africa, for example, can't feed their people. So these people start to leave and go other places, climate refugees. We saw that with Hurricane Maria. Maria destroyed many Caribbean islands. And so those people literally had to leave their homes and move to Florida and other places because they had nowhere to go. Those are climate refugees. And I think that's just going to be a continued problem going forward. And it's going to exacerbate already tense immigration policies in Europe and the United States.
Right. And I want to ask something in particular about COVID-19 now. It's a little different, which was, like you mentioned earlier, a lot of people are starting to see for the first time the effects of smog, or the fact that the sky looks bluer than it did before. Do you think that's helping when people understand, like, maybe the way we've been doing things needs to change, or do you think that's just an anomaly?
Well, I think it's an anomaly. I think it does prove that we can change the atmosphere, humans, because people say that we can't. I think this little period of time in COVID-19 is showing, we do. But unfortunately, I think when we kind of go back to something of normalcy, I think we'll see pollution levels and emission levels spike right back up there. And so I'm hoping that a few people will kind of go, oh, the light bulb will go off in their minds. Oh, yeah, we are changing things. And so maybe they'll change some of their practices.
Okay. And I wanted to ask you one other thing, Dr. Shehperd, which is, a lot of people sometimes they feel as if climate change is too big, too broad to do anything. Do you have anything you can tell people that would help with climate change, or something that they can do?
Vote climate. That's what I mean, yeah, we can all change our light bulbs and drive hybrids and electrical vehicles. I have a hybrid. I don't eat as much meat as I used to. Those are some individual things that people can do, fly less. But those are what I call incremental solutions. We're going to have large transformational policy changes at the national and international level to deal with climate change through adaptation and mitigation strategies. And that's only going to come through leaders that are thinking about climate.
Okay. And I want to ask you also, which is, if in terms of climate change, is there any way in particular that, if, again, I want to teach somebody one thing we learned from this conversation, where could I go to learn more about climate change?
Okay, I will answer that question, but I just want to also clarify something that's a kind of a myth. Voting climate doesn't mean voting Democrat. There are good Republicans and Democrats and other independents on that very much get it about climate change. So I want to make the point, because there's this myth out there that if you're for voting changes if you're worried about climate change, you're liberal, and if you're sort of a climate skeptic, you're conservative. That's not the case. There are many conservatives that get it and vice versa. But to kind of really beef up or bone up on climate change, there are a couple of places I recommend. Certainly following credible people on climate science like me, or Dr. Catherine Hayhoe, or Dr. Kimberly Cobb at Georgia Tech, for example. You can learn more about our efforts in the state of Georgia with our Georgia Climate Project website, or the Drawdown Georgia effort that's going on in the state right now, both of which I'm involved with. There's also a really good website that I point people to called climate.gov. It's run by NOAA. And it's got a lot of really good resources and basic information. And read my Forbes articles. I'm usually writing about these things, and I try to write it in a way that's scientifically rigorous, but really accessible to the public.
Okay. Oh, before we get out of here, can you explain what the Georgia Climate Project was?
Well, the Georgia Climate Project is a consortium of University of Georgia, Emory University, Georgia Tech scholars, and now has broadly expanded to other universities in the state too, that have come together to try to think about nonpartisan, non-confrontational ways that we can advance the state on climate, whether it be in business, policy, et cetera. So there's a website that you can go to check it out. We've produced a series of videos called the Georgia Climate Stories, which tell real stories of real Georgians being impacted by climate change. That's a blueberry farmer, for example, just very not sort of scientists or ivory tower folks like me. But then related to that, but a separate project, is a Georgia Drawdown, or Drawdown Georgia. Both of these efforts are funded, by the way, by the Ray C. Anderson Foundation. Shout out to the Ray C. Anderson Foundation, real pillars of our community. And that is it's a Georgia Tech, and Emory effort to look at ways that we can think about solutions to helping us reduce carbon emissions in the state of Georgia.
Okay. And so thank you again, Dr. Shehperd. If there's anything you want people to know about you and your work, where would you want to guide them besides those
Yeah,
Instagram?
as you know, King, because you're one of my avid followers, and I appreciate it. You can follow me at Dr. Shehperd 2013 on Twitter. That's DRSHEPHERD 2013. I'm also on Instagram, Marsh for FSU. I just kind of share more pictures and stuff there, and I also have a public Facebook page too. But definitely, get at me on those social media because I try to use those platforms to educate.
Okay. Thank you once again, Dr. Shehperd. And I really do suggest you guys check out what he does on Twitter. Check out his Forbes articles. They are some of the most easy to understand pieces of literature on climate change. I would say if you get some chance, I'll put the links below. Make sure that you check out his climate change talks. He has 3 TED Talks plus probably at least 100 additional talks on YouTube. So there is a climate change video on everything basically from Dr. Shehperd. Once again, I am King Williams. Thank you guys for listening. Please like and subscribe wherever you heard this podcast at. I would also like you to refer to my newsletter you can check out at iamkingwilliams.substack.com, iamkingwilliams.substack.com. Thank you once again for Dr. Shehperd coming in. And thank you guys. If you know someone else who I should talk to in Atlanta who's making a real impact, please let me know on Twitter or Instagram at iamkingwilliams. Again, on Twitter or Instagram at iamkingwilliams. Thank you very much.